Hey guys, here's the spiral review for Spiral 4. As a note, this says no calculator. Your spiral is definitely no calculator this time around. Okay, first things first, we're looking at a value for k such that the slope between these 2 points is -2. First things first, I might set up my slope, so that's going to be k minus -3 over 4 minus 1 is equal to -2. Some of the things I'm seeing is people switching these points around or doing x over y instead of y over x. K plus 3 over 3 is equal to -2. And by the way, that -2 just came directly from that sentence. I'm going to multiply both sides by 3 to get rid of that denominator. And I've got -6 is equal to k plus 3 minus 3 minus 3. K equals -9. Next up, we're writing an equation for a line parallel to y equals 3 through the point 0, -1. First thing I might want to do is take a look at y equals 3. And thanks to Mr. McGillen, who, if you would kindly mention to him that I mentioned him in a spiral review, we know that if y equals 3, okay, 1, 2, 3, I'm going up the y-axis, and y, oh y, are you so beautiful, horizon, I know this is a horizontal line through y equals 3. Now on to the main event. Through the point 0, -1, a horizontal line would have the equation y equals -1. If you recognize from the outset that horizontal lines have an equation in the form y equals, you could jump straight to that without having to draw things out. But if you'd like to draw things out, that can be helpful. Question 3. Write an equation of the line perpendicular to y equals 2x minus 2 through -3, -1. Okay, step 1. I know that the slope of my original line is 2. Perpendicular slope means that we're doing the reciprocal, so 1/2, and making it negative, or you're taking the opposite sign. So that's my slope. Second thing, I need a point. Oh, look, they give me a point. So point slope, we're looking at y equals y1 plus m x minus x1. And if I plug stuff in, we get y is equal to -1 plus -1/2 x minus -3. You could also have written this as y plus 1 is equal to -1/2 x plus 3, and that would be acceptable as well. Write an equation of the line parallel to this guy through another point. Okay. Parallel means same slope. Just like perpendicular was the negative reciprocal, parallel is same slope. My slope here is -4. Okay, y minus 1 is equal to -4 times the quantity x minus -5, otherwise known as y is equal to 1 plus -4, x plus 5, or something along those lines. Question 5, sketching and graph the following function. This is in point slope form. If I'm feeling punchy, and you know I'm always feeling punchy, I might recognize that this is the point -2, -1. All right, that's here, and a slope of 3. 1, 2, 3 over 1. 1, 2, 3 over 1. I wonder if I can get a line to come out well on this. I guess we'll see. And the answer is no. Although I can kind of get that to sort of fit in there. Oh, what the heck. I'm going to delete that and just do what I was going to do anyway. Way better. You can see that I used the point that I was given. And then I used the slope of 3, so up 3 and 1 to the right. As an alternative, I could have solved for y. And that would have been y is equal to 3x, that's going to be plus 6 minus 1, or y equals 3x plus 5. You might notice that I've got a y-intercept of 5 and a slope of 3, which fits this equation. Oh, look, that's everything on the first page. I'm going to draw a smiley face in highlighter with a nose. Question 6, we're looking at a piecewise function. First thing I like to do is to go in and add what I call my force fields. So at x is less than 3, okay, we're going to see a force field at 3. That takes care of those guys, and that at 5, I'm going to see a second one. Okay, I'm going to graph all three of these things separately. So 2x minus 2, that's where x is less than 3. So we're looking to the left. I'm going to write that down here, 2x minus 2. In the middle, between 3 and 5, I've got 1. And then above 5, so that's to the right of my last barrier, I've got negative x plus 5. Okay. So first things first, let's take a look here. 2x minus 2 means that I'm starting at a y-intercept of 2, going up 1 and up 2 over 1. It's going to look something like this. And because I have a less than but not a less than or equals, we're going to have an open circle at the end. Cool. Next thing, I've got y equals 1. That means we've got a graph at a height of 1. And it's only going to show up between these two barriers. It's not going to show up on either side. Both ends of this are going to be closed circles because they are both greater than or less than or equals to. Finally, we've got negative x plus 5. Okay, I'm going to start at a y-intercept of 5 with a slope of negative 1. It's going to go down, go down, go down. None of this part is going to end up showing up until I get past this barrier. And then once we're to the right, my line is going to show up. Okay? Because we're looking at greater than again, I'm going to have an open circle. Number 7, let's graph this in 2 separate ways. Did he say 2 ways? He did say 2 ways. Woo! First up, I'm going to think about this like a mother function that it is, and I'm going to start based on my graph of y is equal to the absolute value of x, which we know has a vertex at 0, 0. First thing that's going to change is that my vertex is going to shift to positive 3, the opposite of what's inside, positive 4. All right, there's my vertex. Second piece of this is that I can use that slopish number out front to describe, okay, I'm going to go down 1 and over 1 and down a half. The negative is going to make this guy look like this. As long as I get a couple points that are in the right area, you can see that my slopes go to all heck after that, and that's fine. You do need to include a couple values that I can tell are correct in order for me to give you credit for that. Way number 2 is that we're going to look at this in terms of a table. A general rule of thumb is start with what makes the inside equal to 0. So I'm going to say 3, I'm going to leave a little bit of space above and below it. And when I plug 3 in, I get 4, because 3 minus 3 is 0. And then if I do 0 times negative a half is 0, and 0 plus 4 is 4. Okay? Choosing a number below that, maybe, I don't know, 2 and 4. Although we're going to see these are not as pleasant for this. Choosing 1 and 5 would have been better, but whatever. You know, I make mistakes too. 2 minus 3 is negative 1. Absolute value makes that positive 1. 1 times negative half is negative a half. Plus 4 is going to be 3.5. Similarly, if I plug in 4, negative a half times the absolute value of 4 minus 3, and then plus 4 is going to be 3.5. You might notice those are the points that we already have on here. And my graph is going to follow that upside down V pattern. Number 8, parts A and B, we've got some solving absolute value equations. First things first, let us get my absolute value part by itself. This is an awesome strategy to use for most of the things we're going to be looking at this year. If you can get the weird part by itself, that's going to make the rest of your life a little bit easier. So plus 8. I've got 11 is equal to 2, absolute value of x minus 5. Divide by 2. 11 over 2 is equal to the absolute value of x minus 5. That's part 1. Part 2. This is going to turn into two different equations. 11 over 2 is equal to x minus 5. That's if that inside is positive. And 11 over 2 is equal to negative the x minus 5, which we can quickly transform into negative x plus 5. Okay? First problem, I'm going to add 5 to both sides, and that's going to become x is 21 over 2. If I were to plug that back in, I end up getting 21 over 2 minus 5 is going to be 11 over 2. Absolute value is still 11 over 2. 2 times 11 over 2 is 11. Minus 8 is 3. Cool, this one works, and I plugged it in to check it. That's a really important step here. Second one, 11 over 2 equals negative x plus 5. If I subtract x from both sides, that's minus 10 over 2. I get a half is equal to negative x. In other words, x is negative a half. Okay, negative a half minus 5 is negative 5.5. Absolute value makes it 5.5. 2 times 5.5 is going to be 11, and 11 minus 8 is going to be 3. Hey, that one works too. So I checked both of those because I didn't want any extraneous solutions. And in this case, both of them worked. Again, it is very important that you check your answers with absolute value. Second problem. This one I've already got the absolute value kind of squared away. So I'm just going to jump to making my two equations. Okay, we've got 2x plus 1 is equal to x minus 4. And I'm going to have negative 2x plus 1 in parentheses is equal to x minus 4. Again, that's because the absolute value takes a look at the inside and makes it positive either way. Solving these equations. Minus x to both sides, and I end up with x minus 1 to both sides equals negative 5. Cool. Let's plug that in. Negative 5 times 2 is negative 10. Negative 10 plus 1 is going to be negative 9. Absolute value of negative 9 is 9. 9 is equal to negative 5 minus 4. 9 equals negative 9. Not true. If something is not true, then that means that that answer is going to be extraneous. So this is an extraneous solution. Our other version, we've got negative 2x minus 1 is equal to x minus 4. I'm going to add 2x and 4 to both sides. I get 3x on the right, and I've got 3 on the left. That means that x is equal to 1. If I plug that in, I get I lost my pencil there. 2 times 1 is 2, plus 3, plus 1 is going to be 3. Absolute value of 3 is still 3. And then I've got 1 minus 4. 3 does not equal negative 3. This is another extraneous solution. In fact, this problem has no solution. It has two extraneous solutions. So no solution would be the correct answer to this problem. However, you do have to show me the steps that you found this to be extraneous. In terms of points, if this were worth 5 points, you get 2 points for one, 2 points for the other, and 1 point for realizing what all that means. Moving ever onward, we've got to solve a system by graphing. Graphing is something that I'm not a huge fan of asking for on these spirals, but I wanted you to keep that in mind, in particular because of what it means to solve. So you start at minus 5. You got a slope of up 3 over 1. It's going to look something like this. And again, as I said, I'm not a huge fan of this because our graphs come out so well all the time. My second one, we're looking at plus 5 and minus a third. So it's going to be down 1 over 3. And to me, the best that I can do based on my awesome graph, so we went to there, that looks like the point 3, 4. And that would be the solution to this system. The solution is where our two graphs have an intersection. Number 10, solving using any method. I noticed that nothing here is easily solved, but if I multiply the bottom equation by 2, I get 10x plus 4y is equal to 12. And top I've got 3x minus 4y is equal to 1. If I add these two equations, I get 13x, 0, and 13. I can eliminate my y's pretty easily. That means that x is equal to 1. If I plug that into my first equation, we get 3 times 1 minus 4y is equal to 1. I'm going to subtract that to the side, and I get y is equal to a half. If I plug both of these values into my bottom equation, this should still be true. So 5 times 1 is 5, plus 2 times a half is 1, equals 6. My solution checks out. So I put a check mark. Get it? Check for checks out. Number 11, we're going to solve using any method. I would totally solve this using elimination, but because I know some of you absolutely love substitution, I'll solve this using substitution. To get the y by itself, I'm probably going to add y to both sides and subtract 6. So I get 2x minus 6 is equal to positive y. And then I'm going to substitute that into my other equation. So 6x minus 3, and then 2x minus 6. Please always practice safe substitution. Use parentheses when you substitute. You're less likely to make mistakes and get the wrong thing coming out. When I distribute this through, 6x minus 6x, and then we get plus 18 is equal to 1. 0 plus 18 is equal to 1. We know that is not true. This does not have a solution. In fact, these two lines, if you were to look at them, would be parallel lines. That solution you could consider extraneous, except that there isn't one to get. We didn't actually get a value for x in this case, so this would be a no solution. And visually, you could say it's because these lines are parallel. And on to my favorite problem, the dreaded 3x3 system of equations. Woo! Z's look like the easiest thing to get rid of because all of them have a coefficient of 1. I might combine the first two equations by doing 2x minus 4y plus z is equal to negative 13. And from that, I could subtract the second equation, x plus 2y minus z is equal to 0. And I end up with 1x. I end up with a negative 6y equals negative 13. Okay. The word of caution I'm going to suggest here is that if you use the first two equations for your first elimination, you have to use the third equation for your second elimination. It doesn't matter which other one you choose to use, but you do have to use that third equation at least once. But I could say 3x minus 2y plus z is equal to negative 10, and from that subtract the second equation if I wanted to. X plus 2y plus z is equal to 0. Okay, 3x minus x is 2x, negative 2y minus 2y is minus 4y, 0 equals negative 10. I now have a system of two equations. Those are given by the things that I'm about to highlight here. And I'm going to treat those as a separate set of equations and begin solving them. So I've got 1x minus 6y is equal to negative 13. And with that, I'm going to include 2x minus 4y is equal to negative 10. Okay? If I multiply my top equation by -2, I get -2x plus 12y is equal to plus 26. Now if I add these two equations together, I get 0, I get 8y, and I get 16, y equals 2. This ends up falling together pretty quickly. From here, I could plug that into that equation, and I get 1x minus 12 is equal to -13. If I add 12 to both sides, I get x is equal to -1. And then I can go back up to the beginning. I kind of like the 0 one. I don't really know why. And if I get -1 plus 2 times 2 is 4, plus z is equal to 0, we end up getting z is -3. A good piece of advice is to go back through and plug these back in to the other equations to check your answer. I am running short on time, so I don't want to do that here. Next up, our only really new thing is to graph the system of inequalities. We're going to briefly talk about this in class after I make this video, but my goal is just to give you a general idea of what's going on here. So first inequality, y is greater than 4. Y equals 4 is a line with a height of 4. The greater than or less than indicates that that should be a dotted line, not a solid line. And greater than 4 means any point above that should be colored in. Woo! So something like this. Next part, x is less than or equal to -2. Okay, for -2, I'm going to do a solid line because we've got less than or equals. And I'm going to shade on the left because -2 is our rightmost bound. The solution to this would be the region that's up here that has both colors, or now in this case all three colors, showing up. For the second one of these, we're graphing y is less than 2. We've got a similar setup. Okay, horizontal line, less than I'm going to shade in below. And then we're looking at y is greater than x plus 1. I'm sorry, greater than or equals, that's why it's getting a solid line. I'm going to plug in a point to check to see if it works. I like plugging in 0. 0 is greater than 0 plus 1. That's false. That means I'm not going to use that side. I am going to use this upper side up here. And the region that would be true in this case would be this triangular region in the bottom left quadrant.